We're back in a fern patch here right now. The third group of plants. We've done algae, we've done the mosses, and now we're going to talk about ferns. And ferns are an interesting plant. And here's you all know what a fern looks like. Here's the classic fern frond, okay? This fern has figured out how to carry water up from the ground, so they're the first plant that got tall. And remember, the mosses were short. The first plant to get tall was a fern. In fact, during the Jurassic period, ferns were 90 to 100 feet tall. They were fern trees. And they were so huge that they could hide dinosaurs and feed dinosaurs. Well, those ferns are gone. But our ferns can't hide dinosaurs anymore. But you know what they can hide? Let's see what's behind these ferns here. They can hide little woodland elves. There, I found some leprechauns. Yes, they hide leprechauns. Oh, there they hide again. Okay. Well, here we are back in another fern valley. And you notice it's lush down here and wet in back of me. You can hear the birds. And I can hear a little bit of water. Because ferns are still a plant that need to live in a wet place. Just like our algae actually had to live in the water, the mosses that we looked at still required water for the spores to help generate new, right? Same thing with ferns. We're still dependent on water. But remember what they invented. They used to hide dinosaurs. Now they just hide leprechauns. But what they invented is vascular tissue, so they can grow higher than the ground. Remember, the mosses were flat. You've all seen, and we've shown you the mosses. They're close to the ground. They only take up water through osmosis. These guys here have invented vascular tissue, which your teacher will talk about. And so they can haul water all the way up to here on these tall ferns. Still, they don't have flowers, isn't part of the deal. But they still use spores, as did the mosses. And so this part of the plant right here is called the frond, and many ferns will create and lose their spores from the bottom of their leaflets on the fronds. This is an interesting fern here called interrupted fern, and you can see there's one frond here, and it looks like it's got little brown dried up leaflets on this frond, but those are indeed the spore-bearing part of the plant. And the spores are created here. They contain all the DNA they need from both actually there are sperm and egg in here, and the spores will land somewhere, and your teacher will show you how that works. But this is not just dried up leaflets. This is the spore-bearing part of the fern. And so you can see why it's called interrupted fern. The frond is interrupted by the spore-bearing part of the fern here. Okay? We're going to move down, and I know where there's another fern with another cool little spore-bearing part to it. Let's go. Well, we're looking for spores again. The spore-bearing part of the plants, remember, ferns are seedless. They generate spores, and they're vascular, so they can grow tall, but they still need water for their spores to do the job to create new ferns. And that's why they're in low areas. We just showed you the interrupted fern. Here's one. This fern, you may have seen this. It's got, looks like an, actually it's called ostrich fern. This kind of looks like an ostrich tail. That's where it gets its name. And this is the spore-bearing part of this fern, the ostrich fern. And I'm going to try and tap some spores onto this piece of paper. And we're going to try and, there you can see. I'll hold this still. And Miss Curtis, oh, there's some little teeny insects coming out too. Can you get in on that? It just looks like finely ground pepper. Each one is a packet of DNA that is going to turn into a new fern plant. They are not seeds, they're spores. And out down below me, down at knee height here, is another member of that's related to this group of plants that have learned how to grow tall because they develop vascular tissue. This is called a horsetail, or there's another type of it called scouring rush. Notice it's tall. These two were gigantic during the days of the dinosaurs. you know, many, many meters high, almost 100 feet high. And this too is spore generating, vascular, so no seeds yet, but it can grow tall. So it has root-like structures to hold it in the ground, and this is one step beyond the mosses, right? Okay, let's move on to our next group.